Hello dear listeners, my name is Max, I am technical specialist in the Csoft group of companies. In this video we'll learn how to create a mesh model in the Salome model. Previously, the model was created in some CAD system and exported in step format. The step format is preferred. Almost every CAD system can open this format. It's important that the model is designed without errors. The mesh generator, Salome, was created in France. The program can be installed on any computer and for free. The program is large and has many models. We changed the program for ourselves and left only two models under the name Geometry and Mesh. The first thing to do is go to the Geometry model. You can see a lot of tools available, but we don't need all of them. First, we import our step format file. Immediately there is a warning that the program has started the file and concluded that the model is written in units of measurement millimeters. The Salome generator works with units of measurement meters, as does the PoligonSoft program. The Salome generator asks us if we want to convert the units of measurement of the model into meters. If you answer yes, then the model is converted from millimeters to meters. All sizes will be in meters. It's not very convenient. Therefore, most often we answer no. That is, we will continue to work in millimeters. Next, we have a new question. Do you want to create a partition? The correct answer is yes. We will discuss this point in the next video. And in the next video, we will click no and do the partition of the bodies manually. All navigation in the mesh generator takes place with the mouse. With the left mouse button, we rotate the model. With the right mouse button, we zoom in or out. With the presses wheel, we move the model. In the object tree, we can click on the eye icon, which allows you to hide or display the selected body. When importing a model, a record of the downloaded file appears in the object tree. Then the program finds 3 bodies in this file. Further, after our agreement on the separation of bodies, we have a new object called partition 1 with the 3 separated bodies. The red lines under the partition 1 tab are links that point to the objects from which these partition objects are made. It's a good practice to check the quality of bodies. Some CAD systems export poorly to the step format. In the geometry model, there is a special check that we can do after or before the partition tool. We need to choose the body we want to check. We can also select the entire object partition 1. Next, we go through Inspection, Check Shape. The program writes that this shape seems to be valid. To be sure, click on the check mark, check also Geometry. We see that there are no errors. We recommend remaining all the bodies to understand where the mold, casting and collector are. Next, we go to the mesh model. A black screen appears and the geometry is extinguished. There is also many tools in the mesh model. There are always large or thin-walled objects in geometry. Usually the largest object is the mold. Firstly, we are going to count only the temperature in the mold, so the mesh can be made large. But there may be difficulties in casting. Since it can be thin-walled, we can reduce the calculation time by reducing the number of elements. At the beginning, we need to create a common mesh for all bodies. We have this unifying object called partition 1. We need to set some maximum dimensions there, which will be used for the mold. We select partition 1 and click on Tool, Create Mesh. A window with parameter settings appears. The program allows you to create different types of meshes, 3D, 2D, etc. We'll talk about this in more detail in the next video. You see a check mark, Create all groups on geometry. This is necessary for us to export to the PoligonSoft program, because our final 3D mesh will be treated as one solid mesh, which is wrong. It will be easier for us to create a 2D mesh at the beginning. Then, if there are errors, it will be easier for us to fix. Next, we set the algorithm. This is which algorithm will be used when creating the mesh. We choose NetGen 1D, 2D, and we set a hypothesis. It is a set of rules in different situations. We choose NetGen 2D parameters since simple settings are used there. A window with hypothesis settings appears where we specify the maximum and minimum sizes of elements. The maximum size is 20 mm. We focus on the largest body in the model, on the mold. The minimum size is 1 mm. We also choose fineness. This is a parameter that indicates the intensity of the size change when the elements of large faces move to the elements of small faces. We often set the cores and usually get a good mesh. We click Apply and Close. In the object tree, the Mesh tab has been created, and in this tab there is a created mesh called Mesh 1. Now we have to specify the dimensions of the elements for small bodies, for example for casting. To do this, we need to create submeshes. There can be any number of them. Let's create a submesh for casting. We right-click on the previously created Mesh 1 and click on the tool Create Submesh. Here we need to choose for which geometry the submesh will be created. We choose the casting. Again, we create a 2D mesh. The algorithm and hypothesis are chosen the same. The maximum size is now taken 5 mm and the minimum size is 1 mm. The values are approximate. It's never clear what size should be applied. And finally, we take cores. It's a good practice to calculate the submeshes first and only then the main mesh. We right-click on the created submesh and select the button Compute Submesh. The mesh is calculated and at the end a window pops up with data about the constructed mesh. Now we can calculate the entire mesh as a whole. We right-click on Mesh 1 and select the button Compute. The mesh is created. It's recommended to check the quality of the 2D mesh, but we will talk about this in the next video, because I don't want to load this video with information. Next, we need to calculate the 3D mesh. We select our mesh, Mesh 1, and go to the Mesh tab, and click on the tool Compute 3D Mesh. After calculating the mesh, a window with detailed information appears. Let's take a look at the resulting mesh in detail. The mesh for the mold turned out to be quite large, but suitable. The mesh for casting turned out to be quite small, but there are clusters of small elements on the fillets as usually happens. In a good way, we had to evaluate the mesh model after creating a 2D mesh, and only after that build a 3D mesh. A useful action is to save the settings file, because sometimes it's necessary to fix something in the mesh model. Now we are exporting our mesh model to MED file. That does not create bulky files, so this format is very convenient. Then the saved file can be opened in the PoligonSoft program. I hope you enjoyed this video. Leave your comments on which video you would like to see in the next video.
Can you keep a secret?
Bye everyone.